This video will cover Unit 4, which is our 3 different types of chemical reactions, single replacement, acid-base, precipitation reactions, and then we'll also cover like solution, solubility, and molarity calculations. So the first thing is just remember some basic terminology. We know that we can create a solution by adding a solute to a solvent. So just make sure you know that the solute is the substance that actually gets dissolved. And then you need to make sure you know this term electrolyte. So remember, electrolyte sounds like electricity. We know we need electrons to conduct electricity. And so we know we need ions. It's those negative and positive ions that are actually helping to conduct that current. If a substance is covalent, remember some of covalent compounds can still dissolve. They're still soluble, but because they don't break apart into ions, they are considered a non-electrolyte. We also have the solubility curve, which is how we can show that solubility actually increases as temperature increases for most of our compounds. It actually decreases for a gas. So cesium sulfate down here is a gas, and so you can see the solubility actually decreases a little bit for that compound. But for most of the solids that we'll talk about, we can just remember that temperature can help increase that solubility. That's like how you make tea, sweet tea, or get your salt water to dissolve. You can heat it up. So one of the questions is how many grams of potassium chloride can be dissolved to make a saturated solution. So remember, saturated is on the line. So I want to look for my KCl line right here in 60 degrees. So I find my 60 degrees KCl, and here's my point right on the line. And if I just track over, that's about 45 grams. Okay. For number 2, it's asking if 20 grams, so we have 20 grams of potassium nitrate, so I have to find potassium nitrate at 60 degrees. So I just find where those 2 points intersect. Okay, and it's asking if it's saturated, supersaturated, or unsaturated. So remember, a saturated solution, we are right on the line. That's telling us the exact amount that it can hold, that it can dissolve. Supersaturated means that we've forced it to dissolve more, usually by increasing the temperature and then cooling it back down. And then we have an unsaturated. Remember, that means that it's holding less than it can. It's below the line, below the limit. So if I just look and see, I'm way below the KCl line. We can see it's actually going off the page here. So this would definitely be a very unsaturated solution. I could add a lot more of that potassium nitrate, KNO3 substance. When we're calculating molarity, remember it's just the M is moles over liters. So for number 1, it's just asking the molarity. So I can just plug in 2.98 moles over 3.00 liters. And I will get a number just under 1. 0.99 molar. Okay. For number 2, it's asking for the molarity, but this time it doesn't give me moles, it gives me grams. So before I can actually plug in moles, I have to convert to grams. So if it's 260 grams of calcium chloride, I can find the molar mass of calcium chloride, which is 40.08 plus 70.9, which is 110.98. So 110.98 grams. Remember, I put grams on the bottom because grams is on the top. And then now I can divide So that means my moles, I got 2.34 moles. Okay, and then it says 300 milliliters. So remember, this has to be in liters. So I have to move my decimal over 3 places. So that's 0.3 liters. So then when I plug that all into my calculator, 2.34 divided by 0.3, you get 7.8 molar. For precipitation reactions, remember we're just going to flip-flop our beginnings and then look at our solubility rules so we can determine if we have a soluble substance or not. So if I flip-flop these, that means instead of Ag, I have Na, and sodium has a 1+ charge, and nitrate has a 1- charge. So those will just cancel out. And then now I have Ag, which has a 1+ charge, silver, and then chloride has a 1- charge. So again, those will just cancel out. So now I can look at solubility. The first rule tells me, or second rule tells me that nitrates are soluble. So that's going to get the AQ. And then for the chlorides, most chlorides are soluble, it says except for silver. So silver would get the S for precipitate or solid. For number 2, again, I'm just flip-flopping the beginning. So instead of a K, it's going to be an Na. And again, that has a 1+ charge. Chlorine has a 1-. Those cancel out. And again, if any point in these practice problems, if you want to pause, try it yourself, and then start it back again to kind of check your answers, that is perfectly fine. So in this case, my potassium 1+, when it crisscrosses down, it's invisible. But the 2 from the sulfate, when it crosses, it's going to show. So we have K2S, my S disappeared, SO4. Okay, so now I can look at my solubility rules and determine my solubility. So NaCl, chlorides are soluble. It's not one of the exceptions. It also, under rule number 1, sodium is always soluble. And then for sulfates, it says most are soluble except barium, strontium, lead, mercury. So potassium, this is soluble. So remember, when we have 2 aqueous products, right, our answer is always no reaction. And you can think back to when we did the drops on the card, when we had 2 things that were both soluble, you didn't actually see anything happen. There was no precipitate formed. It didn't get cloudy. So it looks like nothing's happening. So we say nothing is happening. No reaction. Okay, for number 3, again, we're just flip-flopping. Potassium and chlorine both have 1+, 1-, so their 1s will cancel out. And then lithium has a 1+, and carbonate has a 2-. So those will actually crisscross. And now I can look at my solubility. So chlorides are going to be soluble, especially potassium is always soluble. And then carbonates, it says they're mostly insoluble except sodium, potassium, and ammonia. So that one's going to get the S for solid or precipitate. All right, for single replacement, remember these are where we use the activity series. So some of our reactions will not take place if it's a less reactive element. So for the first one, I know that, remember, like is trying to replace like. So if I go through and look at my charges from the periodic table, I know aluminum's going to try to replace iron. So I can look at the activity series. Let's see if I have that one on this slide. Let me grab right here. So here's my activity series right here. So I'm looking to see, is aluminum, there's aluminum, and it is above iron. So yes, my reaction will take place. So now iron is by itself, and then the aluminum is going to bond with chlorine. So these will crisscross, and we'll end up with AlCl3. Okay, for the next one, calcium and sodium. Calcium is here above sodium, yes. So that means yes, this reaction will take place. So remember calcium, if I just look at my charges, it's going to replace sodium. So now sodium is by itself, and calcium chloride. And again, I just crisscrossed my charges for that. For number 3, copper is trying to replace potassium, but I can look here and see that copper is way down here, and then potassium is way up here. So this reaction will not take place. So I will just say no reaction. Okay. Really quick, let's use these examples to review oxidation numbers. So I'll change my pen here. So remember, if anything's by itself, it's always 0. So I have 2 things that are by themselves, so they're 0. Chlorine, remember, is usually -1. So I can go put in my -1s for chlorine. And then I know that I want, for iron chloride, this is a neutral compound, so I want both of these to add up to 0. So I have 2 -1s. That means iron has to be +2. For aluminum chloride, I have 3 -1s, so that means aluminum has to be +3. So if I want to look and see what's oxidized and what's reduced, I can see that aluminum went from 0 up to +3, and iron went from +2 down to 0. So my iron is reduced, and aluminum is oxidized. Chlorine is again one of those spectator ions. It's not, nothing's happening, it's not changing. For the next one, again, calcium, sodium by themselves, 0. Chlorine gets its -1, and then I want them to add up to 0. So that means sodium has to be a +1, calcium has to be +2. So I can look, sodium went from +1 down to 0. So that means it's reduced. And then calcium went from 0 up to +2. So that means it's oxidized. For number 3, nothing is oxidized or reduced because there was no reaction. Also, yeah. All right, last thing is acids and bases. So remember just a couple of characteristics about each of those. Make sure you know the difference between each of these. Specifically, that our acids are producing those H ions. Sometimes we say hydronium because that H ion kind of interacts with water. And then the OH ions for the base. Remember, dilute and concentrated, that just has to do with the amount that you have. This was one of the more commonly missed questions on the Unit 4 test. We know a dilute solution only has a little of the solute, and then concentrated has a lot. That doesn't have anything to do with the strength of the acid or the base necessarily. I could have a dilute solution that is stronger than a concentrated solution if it was a weak concentrated weak acid versus a strong dilute acid. So just think about amount for that one. Strong and weak is where we're getting into our dissociated and undissociated. So this picture would never, I can't call it a strong acid or base without understanding what's being dissociated or how much is being dissociated. I could say it's concentrated, but I can't use the word strong or weak yet because I just don't know. For calculations, remember you're just plugging this into your calculator. You're just going to type in negative log and then whatever your H concentration is. So in this case, it would be 3.2 times 10 to the minus 4. So I get 3.5. So if it's a pH of 3.5, I know that's less than 7, so I could call that an acid. For the next one, negative log 1.3 times 10 to the minus 8. Type that in your calculator. And I get 7.9. Again, if it's over 7, it's a base. So we could call this a base. Sometimes you're not given pH, but you can calculate the pOH. And remember, they both have to add up to 14. So in this case, I could just do 14 minus 3. So the pH is 11. 14 minus 8. The pH is 6. So this would be a base, and this would be an acid. All right. Lastly, we have a titration calculation. So remember, this is just where we use the very similar formula to a dilution. Same formula. Basically, we're just using acid and base instead of 1 and 2. So I'm just going to plug in what I'm given. One mistake I saw on the Unit 4 test was just flip-flopping numbers. So make sure your volume of your base is always going with the molarity of your base. So in this one, it tells me 250 milliliters, 2.5 molar NaOH. So remember, OH is my base. So I'm going to plug in 2.5 and 250. Okay, now it's talking about an acid. So it says I have 75 milliliters of HCl, but it doesn't know the molarity. So 75, and I can leave my molarity as the variable, unknown. So then when I solve, I can divide by 75. Those are going to cancel. So in my calculator, I can type out 2.5 times 250 divided by 75, and I got 8.3. So that is the molarity of the acid. Make sure you know the basic information about endo and exothermic reactions, just the definitions, right? Endo, they're absorbing energy. That means that we can usually measure the temp decreasing. Exothermic, they're releasing energy. That means we can measure the temp increasing. And we can see for endo, we have a high activation energy. And for exo, we have a low activation energy. And we can see it's releasing all that extra energy. The chemical equilibrium or Le Chatelier's principle is the last thing. This is just, remember, wanting to make sure everything on both sides is equal. So if I have increase element A, compound A, right? Now that means the left side has more, so it's going to shift to the right in order to even out. If I increase C, that means now the right side has more, so that means it needs to shift to the left in order to even out. If I remove B, so that means take some out, that means the left side has less, so it's going to shift to the left to even out both sides. Remember, increasing pressure, I have to count my number of moles. So on the left side, I have 3 moles, and on the right side, I only have 2 moles, so we're always going to shift where there's fewest number of moles, because that's where they have the most space to move around. And then for heat, this is an exothermic reaction because it has heat as a product. If I decrease the heat, that means it's going to shift to the right in order to try to fill that side of the bucket back up. And that is the last topic